The carbonyl compounds. Under carbonyl compounds, we learn about aldehydes and ketones. Aldehyde and ketones. Okay. Let us see the nomenclature first. Nomenclature. Nomenclature. Nomenclature of aldehydes. Again, aldehydes nomenclature. See, aldehydes suffix. What is the suffix for aldehydes? Suffix for aldehydes. All aldehydes end with all. Al, all. Aldehyde, all. What is the functional group? Functional group formula for aldehydes? CHO. CHOR, C double bond OH. CHOR, C double bond OH. Okay. Adiba, you should join the beginning only. Okay. You should join by time, Adiba. Okay. Yeah. First page only. Just now I started. Okay. Just now I started. Right. Like last week, this week also, majority of the questions came from our discussion only. Organic questions, SPL, and even some physical questions also. I'll analyze the paper and I'll send in the group. Okay. Physical questions also. Some as it is questions came, and organic also, most of the questions from our discussion only, right? So I'll ask individually, okay, after the class, right? And at 9 to 9:10 between, you can join for the doubts, okay? Because the different students are having different doubts, right? We will do question paper also, okay? Right. Next topic. Or chapter, aldehydes, ketones. Under carbonyl compounds we learn. Okay. First topic is aldehydes. Aldehydes is suffix al, means all aldehydes end with al. And the formula for aldehyde is CHO or C double bond OH. Both are same only. Sometimes we can see the bond line representation also like this. So don't get confusion. If you observe this type of structure or unit, that is aldehyde. CHO, C double bond OH, or terminal C double bond OH represent aldehydes, right? All aldehydes end with name AL. Nomenclature is very important. You know, some questions will come based on the names. You will get formaldehyde, acetaldehyde, acetophenone, like that. Names you will get sometimes, right? Instead of structures. Clear? So don't neglect the nomenclature and try to practice the structures. Clear? Right. First compound. HCHO, or it can be represented like this, H C double bond OH. Right. How many carbons are present in this? Tell me. How many carbons are present? One carbon is present. So if one carbon is present, meth. Is there any carbon-carbon double bond? No. Carbon-carbon triple bond? No. Clear? Double bond is there, but not between carbon and carbon, between carbon and oxygen. So we'll take ane. When carbon-carbon double bond, triple bonds are not present in the entire structure, you can take ane. All. Why we are writing all? Because aldehyde. So the formula methanol. Meth plus ane plus all, methanol. First compound, IUPAC's name is methanol. See, I am mentioning common name, important common name in the square bracket or brackets. See, if I give star marks, that is very important. You should learn without fail. Okay, must and should, you should learn. Formaldehyde. Very important common name. Formaldehyde. How many of the following will give tolerance test? You will get the names only: formaldehyde, acetaldehyde, benzoaldehyde, like that. Okay, clear? Right, first compound and important compound, formaldehyde or methanol, not all, methanol, AL. Right, second one, Shall we go to second page? Next page. All of you. See, this is most important chapter and more weighted chapter. Don't miss a single day also. Okay. Weightage is more and chapter also very big chapter. Vast topics are there in this and linked to one another, interlinked. If you skip one day class, you cannot understand next day. Remember that. CH3, CHO. It can be written like this also. CH3, CHO can be written as C double bond H. Or this compound can be written like this also. Okay. This one, this one, this one. All are same only. All are same only. Okay. Right. How many carbons are present in this? How many carbons are present? 2 carbons are ethanol. Eth plus N plus R. Ethanol. Ethanol. IUPAC name is okay. Ethanol. What about common name? Acetaldehyde. Acetaldehyde. Acetaldehyde are also called as ethanol. Ethanol. Ethanol, ethanol, both are different. Okay. Right. See what I am doing from acetaldehyde. I am removing 3 hydrogen atoms. Okay. See here we have 3 hydrogens, right? 3 hydrogens. I am removing 3 hydrogens and I am placing chlorine atoms. Okay. We have 3 hydrogens. I am removing 3 hydrogens and placing chlorines. Can you try its name? Can you try its name? IUPAC name? 1, 2. At second position, how many chlorines are there? At second position, 2, 2, 2. Trichloroethanol, ALOL. Its common name is very important. Its common name, trichloroacetaldehyde, or also called as chloral. Very important common name, chloral. Chloral is trichloroacetaldehyde, R22 trichloroethanol. It is also called as trichloroacetaldehyde, R222 trichloroethanol. Simply chloral. Chloral is important common name. Clear? 3 compounds are over. Next. It is better to follow the PDF, clear, instead of writing, or take screenshots and you can write later. Okay. Are you writing the notes? Are you writing the notes or simply listening? Okay, okay, but we have notes also. Good PDF for this. Because we can complete the portion and we will focus on the practice, that's why. If you agree. Shall I send the PDF to you? Instead of that, can you manage? Can you manage? Or if you wanted to write the notes, then take screenshots and write later. Okay. That is good actually. You no need to write the notes also. Just make one file, soft copy, right? Because practice is also important, right? Day by day syllabus is increasing. Like that. 4th one. See, if double bond is present, you know, priority goes to double bond or functional group. When double bond is present, priority goes to functional group. Remember, when double bond is present along with other functional group, priority goes to functional group only, not to the double bond. Right? A double bond will present at the bottom. Carboxylic acid, ester, amide, so on, alkene, alkyne are present at the bottom. Remaining functional groups are present at the top. Okay. So start the numbering from the carbonyl carbon. This is called carbonyl carbon. Carbonyl carbon or aldehydic carbon. Now, how to give the name for this? First, write the root word. What is the root word? Prop. And double bond is present at second position. Prop 2 in aldehyde 1 all. Or you can write simply all, because aldehyde is a terminal functional group. You no need to mention. If you mention 1, nothing will happen. You can write like this also, 2-propanol. This is also correct. 2-propanol, right? And its common name, acrolein. AC. This is AC. Acrolein. Acrolein are also called as acraldehyde. Acrolein or acraldehyde. So IUPAC name is already given to you. This is also important compound. Okay. Got it, all of you? Online students. Shall we go to next example? Next example. It's IUPAC name and common name. Give numbering 1, 2, 3. 1, 2, 3. But third position, benzene ring is present. When benzene is present as a substituent, we use phenyl. Prefix phenyl. Third position, phenyl. 3-phenyl. At third position, phenyl is present. 3-phenyl. Prop. Double bond is present at prop 2 in 1 all. Third position, phenyl. Next root word, right root word, prop. At second, double bond. At first, all. Okay, right. Normal method only, procedure only. IUPAC rules, everything is normal only. Here you are learning common names. Cinnamaldehyde. Commonly it is called as cinnamaldehyde. Acrolein or acraldehyde, previous example. Cinnamaldehyde. Right, next compound. I'll send the PDF also. Okay, for nomenclature, basic part only. For nomenclature, you no need to write. If you follow PDF, that is also enough, right? Can you give its name, anybody? Based on the previous 2 examples, can you give its name? Yeah, but 2 in 1 all, or simply all also correct. Crotonaldehyde. This is the product of aldol condensation. There, how you will get the question? They'll give the reaction. They'll ask like this: what is the IUPAC name of the product? This is aldol condensation reaction product. Important. Crotonaldehyde, right? Next. It's common. First, I'll give you common name: glyoxal. Glyoxal, or also called as ethane 1,2-diol. Ethane 1,2-diol. Ethane. 2 carbons are there, na? So ether. 2 aldehyde groups are there. If 1 aldehyde is present, then we use all. If 2 aldehydes are present, we use diol. But what is the position? 1, 2. Ethane 1,2-diol. Common name is important. Glyoxal. Okay. Right. Next, let us try some different example. Just a second, wait. CHO. Anybody, can you try its name? It is a special type of compound, right? A special type in the sense, see, the numbering starts from the carbon other than functional group. See, if you take normal example, numbering will start from the aldehydic carbon, always. Numbering should start from aldehydic carbon. But in this compound, if we start numbering from this carbon, this functional group carbon, now observe what happens. This carbon will get a 4. The same only, na? This is CHO, this is also CHO. This is getting number 1. Good. This is getting number 4. How it is possible? Right? Sir, ఆల్రెడీ స్టార్ట్ అయింది యాక్చువల్గా. మీరు ఇక్కడే ఉండండి, అయిపోతుంది ఇప్పుడు. రేపటి నుంచి టైంకి వచ్చేసేయండి, సరే? ఇప్పుడు అయిపోతుంది, 8:10కి అయిపోతుంది. 8:10, హాఫ్ అన్ అవర్లో అయిపోతుంది. రేపటి నుంచి మీకు 6కి వచ్చేసేయండి. 6 నేను ఏదన్నా ఉంటే చేంజెస్ మీకు చెప్తాను, సరేనా? ఓకే, రైట్. Right, see, look at this, all of you. Let us take one simple example, simple aldehyde. Numbering should start from the functional group carbon only, always. If we do in the same way, like this, one aldehydic carbon is getting 1, another aldehydic carbon is getting 5, and another aldehyde is missing also, not getting any number. So this is not correct. Clear? You are giving first rank to this one functional group, fifth rank to another functional group, but both are same only, no? Then how? Generally carboxylic acid will get high period, first rank. Esters, like that. Clear? Alcohol present at the bottom. This is aldehyde, this is also aldehyde. How can you give first rank to one aldehyde, second, fifth rank to another aldehyde? So to avoid this, don't start numbering from the aldehydic carbon in these cases, these type of cases. Same situation will come in the next chapter also, right? So instead of starting numbering from the functional group carbon in a normal IUPAC system, we start numbering from the carbon other than the functional group, So we will start like this, 1, 2, 3. So we give numbering from the carbon other than the functional group, right? See, this is one carbon, this is another carbon, this is another carbon. Total we have 3 carbons. So if 3 carbons are present, then what is the root word? Propane. At the first position aldehyde is there, 1. At second also aldehyde is there. At third also aldehyde is there. So propane 1, 2, 3. Total how many aldehydes are there? 3. So try carbaldehyde. See, when we use the word carba, when functional group is not included in the numbering, we not included functional group in the numbering, right? There is no number of the functional group. In this case, you will get special word carbaldehyde, carboxylic acid, carbonitrile, carba, special word will come. Otherwise, normal all ethanol, methanol, propanol, like that. Carba special word will come when functional group is not included in the numbering. Clear? Online students? Propane 1, 2, 3, tricarbaldehyde. When carba word will come?
When we use the nomenclature.
Yeah. Online students, did you get this? Carba word. Is it okay for everybody? Respond. Next. CHO. cyclohexane. This is not benzene ring. Cyclohexane. Tell me, this is cyclohexanol. Correct or no? Cyclohexanol. Kritika, is it correct? Cyclohexanol is not correct. Cyclohexanol. Yes, this is wrong. Why? Again, this is wrong. See, in the ring, functional group carbon is not including. In this case also. See, observe this ring. It is a 6-member ring. In this ring, functional group carbon is not included. It is away from the ring, out of the ring. So in this case also, special word will come, carbaldehyde. Cyclohexane carbaldehyde. Cyclohexane carbaldehyde. Cyclohexane carbaldehyde. If 6 carbons are present, hexa. Cyclohexane carbaldehyde. Let us start aromatic aldehyde. Are you following, everybody? Mazia, Srinidhi, follow the names. Srinidhi. Kritika, unnava nuvu? Kritika. Surabhi, follow tunnara? Surabhi, meer. Yeah. See, please, when a request or order or command, don't miss Carbonyl's chapter, single class also. In this, different reactions will come. Condensation reactions are very important for the final exam. This vast chapter and important also, more weightage. Without question from this chapter, there is no paper, final neat paper. Okay, more weightage chapter. You can expect 2 questions from this. Right, so we are going with the basic level only today. Next you will get important named reactions with mechanisms. Okay, we'll let big mechanisms. Without mechanisms, it is difficult to answer. Right. Let us start aromatic. Benzene ring with CHO. Benzaldehyde. The direct. Remember, benzene ring with CHO is called benzaldehyde. It's a common name. Vanillin, flavoring agent. Vanillin, I give an important common name first. After that, IUPAC name. You tell me parent structure name. Parent structure name is benzaldehyde, right? Close this. This is benzaldehyde. Now give the numbering from the carbon which is attached to CHO, aldehyde. 1. After that, you tell me, should we go right or left? Right, because if you go like this, you are getting substituent at the 3rd position. If you go like this, 1, 2, 3 at 4th position, remaining all will become substituents only. This is the parent unit, major functional group benzaldehyde, remaining are substituents. So 4 hydroxy 3 methoxy benzaldehyde. 4 hydroxy 3 methoxy benzaldehyde. Commonly called as vanillin. It's a flavoring agent. Okay. Right. Next compound's name, came in the last chapter of phenols chapter, right? If OH group and CHO are present side by side, then that is called as, what is its name? Salicylaldehyde. 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 Correct or no? Salicylaldehyde. Or orthohydroxybenzoaldehyde. Orthohydroxybenzoaldehyde. Salicylaldehyde. Both are same. Can you give its name? This is very, very easy. Anybody? Can you give its name? Paranitrobenzoaldehyde. P-nitro. Why I am giving these compounds? We have reactivity comparison in the coming classes. Which of the following is more reactive? Paranitrobenzoaldehyde, orthonitrobenzoaldehyde, metanitrobenzoaldehyde. Reactivity. You have nucleophilic reactions this week only. Again, we use this compound. Same example. We use the same example. Paranitrobenzoaldehyde. Paranitrobenzoaldehyde. If I give another NO2 group, specific, okay, another NO2 group, all are attending the first day with full presence. Okay, later strength is decreasing. So what I will do? I'll plan to take the extra classes. Let us focus more on the practice. Okay, like some 20 minutes extra classes when I get the free time daily, right? Because the weekend strength is decreasing and they are focusing on the botany zoology only. So everyone should cooperate and attend extra classes, just short duration classes only, like 20 minutes, like that. The 20 minutes is also very important to us, clear? In this 1 hour, how 20 minutes is important. So if I take another 20 minutes, that is benefit only, no? That means we can finish the portion fast. Give its name. 1, 2, 3, 4, 5, 6. 2,4-dinitrobenzoaldehyde. 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 We have reactivity comparison. Which of the following is more reactive towards nucleophilic addition? Okay, we will discuss later. Between these two, which is more reactive, we will discuss later. Mostly day after tomorrow, we will start. If I take extra classes. Because preparations take more time. You want to believe, you check NTA JEE Mains exam, NTA NEET exam. Without aldehyde preparations, there is no paper. Most important named reactions are there in this. Under named reactions, questions will come. Clemenson reduction, Wolff-Kishner reduction, Stephen's aldehyde synthesis, benzoin condensation, Kenizaro reaction. So many named reactions are there in this chapter. Right. Next, ketones nomenclature. Ketones. How many carbons are required to write one ketone? To draw one ketone structure? Number of minimum, yes. Minimum we need 3 carbons. With the 3 carbons we can frame the ketone. Ketones general formula and the suffix for ketones is -one. Ketones. See, whenever you observe R, C double bond O R, the name of that compound ends with the -one. One simple ketone CH3, C double bond O CH3. Don't neglect the names. How questions will come? How many of the following gives Tollens test, valence test, Benedict's test? Names will come, not structures. Acetone, propanone, acetophenone, benzophenone, like that, cyclohexanone. And see, while covering the nomenclature, I'll tell you some other additional points also which are useful for the reactions. Actually, you won't get that type of concepts anywhere, clear? For example, I'm teaching the ketone now. Wait for 2 to 3 minutes. I'll give you one important point that are very useful for the reactions, right? So we cover the important points which are useful for the reactions also while nomenclature discussion, right? Its name is, and in this how many carbons are present? 3 carbons are present. Everyone will give its name. What is its name? Prop. 3 carbons are there, so prop plus ane. Why we are writing ane? Is there any carbon carbon double bond? No. Carbon carbon triple bond? No. So write ane. And one. Why we are writing on? C double bond O is there. Prop plus ane plus one, propanone. 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 Right. Keep star mark for the common name. Acetone. Acetone. First important name, acetone. Tell me, Meenakshi. No. Actually, see, numbering will start from the 5 carbon onwards. I'll tell you why. Why we no need to give the numbering in this case. Numbering will start from the 5 carbons onwards, not even 4 carbons also. I'll tell you, wait for some time. I'll cover that examples also. Right. Apart from this common name, one very important point you are going to learn. See that point, all of you. Important for the name reaction, haloform test. All of you stop writing. If you write, look at the board. Put C double bond O in a box. Put the functional group in a box. Put the functional group in a box. Okay. This is FG functional group. Functional group. The position which is next to functional group is called as alpha position. Alpha position. You should learn the basics here only. Clear. In coming classes we go with reactions directly, right? So focus on the basics, basic points. Alpha position. This is also alpha position. The position or the carbon which is next to functional group or which is adjacent to functional group is called alpha position, and this is called alpha methyl. Identifying alpha methyl in a given ketone is important. Alpha methyl group means the methyl group which is directly connected to C double bond. This is one alpha methyl. This is one alpha methyl. 2 alpha methyl groups are there. Which of the following ketone gives haloform test? Condition for haloform test is presence of at least one alpha methyl group. Haloform reaction is there. Okay, ketones undergo haloform reaction. Which ketones undergo haloform reaction? Ketones with at least one alpha methyl group. So we are learning other basics also under nomenclature. Clear? So acetone contains 2 alpha methyl groups, or propanone contains 2 alpha methyl groups. Right? Next. Now I'll give you clarity why we do not give the numbering when 4 carbons or 3 carbons are present. 1, 2, 3, 4. Assume we can give the numbering. Just assume. Say based on the numbering 2 butanone, because C double bond O is at the second position, 2 butanone. Now shift the C double bond O this side and CH to this side. Just interchange. CH3, CH2, C double bond O, CH3. What we did, just we swapped. Okay. And now give the numbering for this. Now numbering will start from this side. What is its name? Again 2 butanone only. Second position C double bond, 2 butanone only. So both are same only. So no need to mention the numbering, right? So just butanone. If you mention numbering, okay, that is also no problem. Nothing will happen. But generally we start numbering from the 5 carbons onwards. Right? Okay. Butanone over. Important point, will it contain alpha methyl group? Is it having alpha methyl? How many alpha methyl groups are there? How many alpha methyl groups are there? 1 or 2? 1 only. This is alpha methyl. This idea is very important. This is not methyl. This is ethyl. Butanone contains only 1 alpha methyl. Right. This is alpha methyl, right? Next, all these will come in the reactions. Okay. Give the numbering for this. Okay, my numbering may be wrong. You write correct numbering. Means this numbers, example numbers. 5 carbons onwards we give the numbering. Clear? Right. 5 carbons are there. Now you can give the numbering. Right. Numbering should start in a direction in which functional group will get a least number, least priority. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In this case, ketone is present at which position? C double bond of carbonyl. Second position. This is 2-pentanone. 2-pentanone. This is 3. Third position, C double bond O is there. 3-pentanone. 3-pentanone and 2-pentanone, which is having alpha methyl. 2-pentanone. So 2-pentanone, 3-pentanone can be distinguished by haloform reaction, because haloform reaction is given by ketones with the alpha methyl group. 3-pentanone do not react with haloform test. You will get these type of questions. Clear? So you should have this idea, alpha methyl concept. Clear? In 2-pentanone, alpha methyl group is there, so it reacts with haloform test, haloform reagent. It do not react with the haloform reagent. And one more important point, we are not writing the bond line structures. Please write bond line structures in every case, all of you. Bond line structures. Write bond line structure for this. 1 C double bond O, here double bond O, CH2 CH3. CH3 C double bond O, CH2 CH3. Bond line structures are important. Clear? Write bond line for this. 1, 2, 3, 4, 5. 5 carbons. Bond line structure. Bond line structure for this bond line structure. Correct only, no?
Yes.
1, 2, 3, 4, 5. Bond line structures are important. We completed alpha methyl concept also. Alpha methyl. Now another important basic point I will give you. Alpha hydrogens concept. Alpha. This is useful in another reaction, tautomerism concept, right? After nomenclature, we go with the isomerism, tautomerism concept. Under nomenclature only, let us start that also. Alpha hydrogen concept. Of course, some of you know very well about that. Alpha hydrogen concept. Alpha hydrogen. You know alpha position? Yes or no? You know alpha position? This is alpha carbon and this position is alpha position. To alpha carbon, I'll write clearly. This is actual structure. This is actual structure. But we write like this, condensed format, right? It is difficult to write now every time like C double bond, C bond H, C bond H, C bond H. So we write condensed form. All together, condensed form. This is alpha carbon. This is alpha carbon. Hydrogen which is connected to alpha carbon is called alpha hydrogen. This is alpha hydrogen. This is alpha hydrogen. This is alpha hydrogen. Alpha hydrogen, alpha hydrogen, alpha hydrogen. So here 3 alpha hydrogens we have. Here also 3 alpha hydrogens we have. What is the use of knowing about alpha hydrogens? The ketone or aldehyde with alpha hydrogen undergo tautomerization. For next topic, this point is useful. Tautomerization. Note down the examples. Alpha hydrogens. Tautomerism. Alpha aldehydes. In aldehydes also you can consider alpha hydrogens. Not only in the ketones. Now this is the functional group. This is alpha position. At this alpha position, 3 alpha hydrogens are there. Knowing about alpha hydrogens is also important point. Okay. Right. Next. Can you tell me in this alpha methyl is present or not? First of all, tell me its name. Tell me its name. And in this alpha methyl group is present or not? In this, its name is, what is its name? Cyclohexanone. Cyclohexanone. 6 carbons are there. Hexa. Ketone one. Cyclohexanone. In this alpha methyl group is present or not? Alpha methyl. Alpha methyl. Online students. Functional group. This is alpha position. This is alpha position. See, this carbon is alpha. Next beta, at beta alpha methyl group is present, not at alpha. There is no alpha methyl. It won't undergo haloform test. No alpha methyl. Actually, see, functional group alpha, beta, beta. 2 betas are there. See, alpha, beta, beta. Alpha, beta, beta. 2 beta positions are possible. But exactly at alpha position, there is no methyl group. Not possible with this example, cyclic examples. There is no alpha. But what is its name? Can you give its name? Its name. This is cyclohexanone. This is methyl cyclohexanone. 2 methyl. At second position, methyl. This is called methyl. 2 methyl cyclohexanone. This is cyclohexanone. 2 methyl cyclohexanone. 2 methyl cyclohexanone. And last 2 important compounds. I'll close. Very, very, very important. Acetophenone and benzophenone. Acetophenone and benzophenone. Acetophenone and benzophenone. Acetophenone. Acetophenone is having alpha methyl, remember. Acetophenone. Benzophenone. Benzophenone. Acetophenone and benzophenone. Very simple. See, all of you. First write C double bond. If one side CH3, one side phenyl ring is present, that is acetophenone. Or methyl phenyl ketone, you can write like this also. Methyl phenyl ketone. Methyl phenyl ketone. Or commonly called as acetophenone, most important name. 2 C double bond, one side benzene ring and one side methyl is present, that is called as acetophenone. Acetophenone. 2 C double bond, 2 sides benzene ring is present, that is called as benzophenone. Remember, in benzophenone, is there any alpha methyl group? In benzophenone, is there any methyl CH3? No, no alpha methyl. No alpha methyl group. Okay? And be ready for the extra classes. Okay? This week onwards, like just like 15-20 minutes, very short duration extra classes, but that will very helpful for us to complete the portion with practice. Okay, everyone should cooperate. Only short duration classes, right? All right. Okay, bye. See you tomorrow. You can attend at 9:10, around 9 or 9:10 for the paper if you have any doubts. Okay, right. Yeah. I'll tell to. I'll tell to sir. Okay. Right. Very short duration only, right? Okay, 15 to 20 minutes only. But if I take 4-15 minutes, that is equal to 1 hour, one extra class. Like that. That is my intention. Okay. Okay, see you all of you. Kritika. Yeah, actually I started before that only. Before we started, this is third chapter, basics only, and